This is a region question, which is primarily based on straight line graphs. So I have to plot the three lines and then shade the false side. So I begin by plotting the first line, x plus y is less than or equal to 6, and I'm just going to use a 0, 0 table to plot the line. So when x is 0, y is 6, and when x is 6, y is 0. So I'll plot the 2 points, put in the line. Now, as I said, we have to shade the false side of the line, so we have to test a point to decide which side is false. Generally, I will use 0, 0 unless it's on the line. So here, if I substitute that in, 0 plus 0 is less than or equal to 6. Well, that's definitely true. If I plot the point 0, 0, that's on the true side, therefore the other side of the line is false. Now the second line I plot is just going to be x equals 2, so I go to 2 on the x-axis and plot the line. Now it's easy to see the values to the right are the bigger values, and the values to the left are smaller than, so I shade the false side. Now the third line I have to plot begins with 2y, so I'm going to rearrange the equation to make y the subject. So we divide by 2, that gives you y is greater than or equal to half x. If I follow y equals mx plus c, the number with the x, which is the gradient, is a half, and the value by itself is c. Well, there is no number there, so it has to be nothing. So I start at 0, 0 and plot the line. Now it looks like I already know where the region is, but I'm going to test a point just to make sure. Now 0, 0 is on the line already, so I'm going to choose the point 1, 0 instead. If I follow that through, remember, just watch out you get the y values and x values in the correct place. 2 loss of y value is 0, x is 1, 0 is not bigger than 1, that is false. Therefore that is the false side of the line, and yes, there is the region. Now, the second part of the question asked me to find the maximum value, and it's an integer question. So what I'm going to do is look for the coordinates inside the region, and in particular at the extreme points. So I'll have a point at 4, 2 and 2, 4. Now there is a point in here as well, but because I'm looking for a maximum, I don't need to consider it. So if I substitute to work out what the maximum value is, so first of all we'll use the point 2, 4. It has to be the 2x plus 3y, so it's 2 times 2 plus 3 times the 4, which gives me a value of 16. I'll then test the point 4, 2. Again, it's 2 times the x value and 3 times the y value, which gives me a value of 14. Therefore, the biggest value I can obtain from the expression is 16, and it occurs at the point 2, 4.